Hi and welcome to this video where I'm going to explain how you can use the enthalpy of formation data to calculate the enthalpy of reaction. Now first off, if you haven't already watched my video on different types of enthalpy, please watch that. And if you cannot remember anything about enthalpy change calculations, please go back and have a look at the level 2 content before you come into this. Otherwise, this is really moving forward into level 3 content. And there will usually be an enthalpy of formation question in your exam, and it's usually worth a merit, give or take. Okay, so we're going to be calculating enthalpy change given standard heats of formation or standard enthalpies of formation. So remember, the enthalpy of reaction is the change in enthalpy that occurs during any reaction. Now, if you have enthalpy of formation data for all reactants and products, you can calculate it, the enthalpy of reaction, from the sum of the enthalpies of formation of the products minus the sum of the enthalpies of formation of the reactants. And remembering that the enthalpy of formation for a pure element is 0. Okay, they will usually include a reaction that has at least one 0 element, because that's another way of finding out really whether you know what you're doing. Okay, so here's an example. This is an actual exam question. So the equation for the combustion of propanol is, as you see, propanol plus oxygen makes carbon dioxide plus water. And you've been provided with enthalpy of formation data for propanol, carbon dioxide and water, and you've been asked to calculate the enthalpy of combustion of propanol. Now, the enthalpy of combustion of propanol you can calculate in this way. So how do you go about doing this? Well, the first thing you're going to do is you're going to write the equation. Okay, so you've been given the balanced chemical equation, you're going to write the mathematical expression for it. Enthalpy of combustion in this case, or it could be the enthalpy of any reaction, is the sum of the formations of the products minus reactants. So remember that capital sigma means the sum of. All right, so what are my products? Well, my products are carbon dioxide, and I've got 3 of them, and water, and there are 4 of them. So that's going to be the sum of the enthalpy of formation of the products minus the reactants. Now my reactants are propanol and oxygen, but of course oxygen is a pure element, and so its enthalpy of formation is 0, so I haven't included it in the formula because 4.5 times 0 is still 0. At that point then it simply becomes a matter of substituting the numbers into the equation and solving it. Now it is important to be aware of signs and brackets. Okay, if you're not sure how to do this, do each calculation step by step. So go 3 times negative 394 equals, write that number down, plus 4 times negative 286 equals, write that number down, minus, write that number down, right? That's a minus and a negative, and then work them all out bit by bit, and then write your answer. Now, a couple of checks. The first thing, this is a combustion reaction, so your product should be a negative number. Your answer should be a negative number, which it is. This is good. We've got a unit in there. That is the next check. Considering significant figures is always a useful thing to do, but isn't always essential. This one here, technically, if you're rounding it to 3 significant figures, would be negative 2,580 kilojoules per mole. However, because all our answers are added and subtracted, we can write it as is, and that is actually quite accurate. If you write all your working down, then even if you make a calculator stuff up, you will get some marks. If you don't, you won't. So the way the marking on this usually works is that writing out the formula and attempting to substitute the numbers into it usually will get you an achieved point. Doing the calculation correctly and getting the correct answer with the correct unit would get you a merit point. And that's really where we're looking at in this. These calculations are too straightforward to be excellence calculations, but I hope you found this useful. Please do have a look, and please do not try and do this type of calculation if you don't have all of your data as enthalpy of formation. If you have a mixture of enthalpy of formation, enthalpy of combustion, sublimation, vaporization, or just reaction, you cannot use this method. It will not work. But you can do it for formation and only for formation. Okay, so just be aware of that. Have a good go at it and see how it works. I'll see you next time.